Evan's uncle bought 2¼ pounds of hamburger meat. Sorry, let that load up here. Evan's uncle bought 2¼ pounds of hamburger meat and used 1/3 of it to make lunch. Okay, so what we talked about this before, what math operation is of?
That's multiplying.
Multiply. So we're going to take 2¼ and multiply it by 1/3.
Okay.
And we could use the picture here, but we're going to do it by hand, and then we'll go back and look and see if the picture is correct here. So for the number on the left, we've got to convert that to an improper fraction. Do you remember us doing that the other day?
Is it like how was it? Did we do it on Monday? But like,
Yes.
okay, yeah.
So
Yeah,
you
I
take
remember that.
you take this bottom number, right? Multiply it by the number in front, add 1 to it.
Okay, let's see. Okay, I got the answer.
What do you got for me?
9/4.
9/4, good. Times 1/3. Now, sometimes you can pre-reduce. Does 9 go into 4? Does 9 go into 3?
9 doesn't, wait, 9 doesn't go into 3.
Or I'm sorry, maybe I said that backwards. Is 9 divisible by 3? Is 9 divisible by this number on the right?
Yeah.
Yeah, so you can divide them both by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. Now you can multiply the top numbers and multiply the bottom numbers.
Okay, I got it.
Okay, what's your final answer here?
3/4.
3/4, good. Excellent. Okay, let's do another problem here. All right, for her science project, Natalie made a volcano that was 1¾ feet tall. The height of the lava that came out of it was 1½ times. What math operation is that?
Multiplication.
Multiplication, yeah. So you're going to take 1¾ and multiply it by 1½ All right, so before you multiply, can you give me the 2 improper fractions that you see there?
So I do like what we did.
Well, just give me the 2. Yes, make each one of these an improper fraction, just like we did in the
Okay.
previous problem. I want you to give me the result before you multiply.
Okay, let me just work it out.
Okay.
Okay, I think I got my final answers.
All right, should be 7/4 and 3/2. Does that look right to you?
Yes, I got it.
Okay, so I want you to multiply the tops and then multiply the bottoms. I'm going to just step away for 30 seconds, but I'll be right back.
Okay.
All right, tell me what you've got here for the top and the bottom.
Okay. For the top, I got 21/8.
Very good. Now, we want to convert this to a mixed number. Okay, I don't think we've done this in a while. You have to take 8 or 21 and divide it by 8. So how many times does 8 go into 21?
21. Um, is it
Like, what is 8 times 1? Let's just start there.
it's what 8, sorry,
Okay, and 8 times 2,
16,
and 8 times 3.
24.
Okay, good. So 21 is between 16 and 24. So which number goes up top here?
Is it 24?
The number that goes up top is the number of times that 8 goes into 21.
So 16.
No, 16 is the multiplication of 8 times 2.
Oh, sorry. It is 2.
2, yes. All right, now this is very important. 2 is your whole number. Okay, the
Okay.
whole number is part of your mixed number. Now let's take 2 times 8. What is 2 times 8?
16.
Okay, we're going to subtract. What's 21 minus 16?
16. 15.
Try again.
Is it 6 or?
No. 21 minus 16. I think you're overthinking this here. You're just counting up from 16 to get to 21. It's okay to count with your fingers, whatever you want to do. Me giving you the answer though isn't going to help.
Okay. Is it 5?
It is 5. Okay, now the remainder goes in your numerator. Okay,
Okay.
and your denominator stays the same. Okay, so let's just be clear here on what we did. We took 21 over 8, and that becomes 2 and 5/8. So let's do another one here. Let's do 13 over 5. Okay.
Okay.
So you take 5 outside the house, 13 inside the house. How many times does 5 go into 13?
Is it 3 times?
Okay, so 5 times 3 is 15. That's too large.
So 2.
2 times. What is 2 times 5?
2 times 5 is 10.
Okay, so go ahead and subtract.
3.
3, good. So 13 over 5 becomes 2. The 2 comes from the top number. The 3 becomes the numerator. And the 5 stays the same. Do you see where all the numbers went? Like we had to divide over here on the right. The number on top becomes the whole number. The remainder is the numerator.
Yes.
Okay, so we're gonna do another one here. Let's say it's 25 over 7. So you got to come off to the right. And you got to do this division here. So I want you to tell me the number that goes up top and then the remainder on the bottom.
Okay, so uh, 3 or
Okay, what is 7 times 3?
it is 21.
21. Now we're going to subtract.
Four.
Okay, good. So there's a whole number, and then there's a numerator, top number, and a denominator. What is the whole number? What goes in front here?
The whole number is 3.
Okay, and what goes in the numerator?
The numerator 4, and then the bottom 7.
Very good. Okay, let me have you try one completely on your own here. Let's go 17 divided by 3. I want you to write this as a mixed number, please.
Can 18, well, because 3 doesn't go into 17, it's closer to 18, right? So I can put that.
You choose the smaller number, the one in between the two.
So 5. Okay. Okay, I got my final answer.
Okay, what's the whole number?
5,
Okay, what goes in the numerator
2,
and the bottom?
3.
Good. All right. I'm tempted to have you do one more, but we're gonna see it. We're gonna see it in the next problem here. So let's have you do one more. That would be good of me. Let's go 55 divided by what we've not done in a while. Let's go 6. And then we'll get back to multiplying mixed and improper numbers.
Okay. Okay. Uh, okay, I believe I'm done.
Okay, what's your whole number?
My whole number is 8.
Okay, 8 times 6 is 48. What is 9 times 6? What's 8 more than 48?
54.
54. So that might change your answer there. Do you want to rework it?
So you want me to do it by 9 now?
Well, it has to be 9. It's not a choice. It's that you didn't get the number that goes the biggest number that goes into 55. It has to be the biggest, which is 9. Is it clear what I'm saying? Like you can't use 8. You can't use 8 and then put, I guess you maybe had like 9 up here. No, I guess you would have had 7 up here.
Yeah.
Yeah, you can't do that.
So you want me to do it by 9?
Yes.
Okay. Boy, I have a question.
Yes.
Um, for the 55 over 6, I'm supposed to do the inside out, wait, boy, inside the house and outside of the house, right?
Right. And 9 is the largest number that goes into 55.
Oh,
You can't just pick a number that you think will work. It has to be the largest one.
oh, I thought it was 6 because we were using 6 outside the house. But okay. 9. Okay, I got my final answer.
Okay. What do you got for me?
9 and 1 over 6.
Very good. All right. So the challenge here for you will be with these new problems is there's just a lot of there's a lot of steps. It's kind of like when you look at a task or a project and you know how to do everything. There's just so much to do. You feel a little bit overwhelmed here. All right. So this is your next question. It's 5/6 times 4 and 1/2. I'll step you through it here. I want you to convert 4 and 1/2 to an improper fraction.
Okay. So then I give you the proper fraction and then
Yep, just give me that improper fraction to start out with. We'll do this in pieces.
okay, I got my final answer.
What do you got?
9 over 2.
Very good. Now, you can pre-reduce here. 9 and 6 are divisible by 3. What is 9 divided by 3?
9 divided by 3 is 27.
You're dividing.
Oh, sorry. The 3, right?
Yes.
So 3.
And 6 divided by 3?
6 divided by 3, 2.
2. Very good. So now you're going to multiply the tops and the bottoms. 5 times 3, 2 times 2. Can you tell me what the numerator becomes in the denominator?
15
Over.
over 4.
Okay. Now we've got to convert this to a mixed number.
Okay. Can 4 go 4? Can 4 go into? Oh no. I got my final answer,
Okay, what's your whole number?
3.
Okay, and the numerator, did you get 3 and 4?
Yes.
Very good. All right, well, that's going to do it for us today. Zoe, good job. Hope you have a great weekend, and I'll see you on Monday.
Okay, thank you.
Welcome. Hey, Michael, how are you today? Hey, Michael, how are you today? All right, you're doing good. You're always doing good. I like that. How's math class going? I'm having a little trouble hearing you. Can you get a little closer to the headset or computer, or just speak a little louder?
Today I didn't have math class because it's Wednesday.
Today's Thursday. So did you not have math class today or yesterday or both?
I didn't have math class today.
Okay. Got it. Well, we've been doing a lot of parallel and perpendicular lines. Let's see what else you got going on here. So it looks like you got a quiz, maybe still there. Looks like you're up to a new topic on classifying shapes. Does that sound familiar?
Yeah.
Okay. Looks like you've done that. That's nice. Let's go take a look at your quiz and let's see what it asks you to find. All right. Here's a problem for us to work on. Before we do that though, let's write a few definitions down that we're going to need. Do you remember the measure of a right angle? What the number is that corresponds with the right angle?
A 90-degree angle.
90 degrees, good. So an acute angle is less than 90. Okay. So what's a number less than 90?
62.
Sure, 62 degrees, good. An obtuse angle
Is more than 90.
is greater than 90. Yeah, you already know these. That's excellent. Now, there's a little caveat. It has to be also less than 180. So it's like up to 180 degrees. So, for example, 135 degrees is an obtuse angle. All right. So let's take a look at a problem here. And it's just angle classification. So you probably already know how to do this here. Let's look at these 4 angles. Oops. Sorry, I'm just trying to get this to be a little bit bigger on the screen there. Angle J. Angle J is up here. Is it an acute, right, or obtuse angle?
A
Do you have those definitions written down from above here?
no.
Okay, can you write them down?
Yeah. Okay. Done.
All right, what did you, okay, so what did you come up with angle J? Angle J is 110 degrees.
So angle J is a obtuse.
It's obtuse, yeah. Let's go to the next angle, angle K. Angle K there.
All right.
It's a right angle. And then angle L, so we're kind of going down this direction. What's angle L?
Acute.
Cute. And how about angle M?
Acute too.
You got it, good. So really not that difficult, would you agree? There's just 3 to remember: obtuse, acute, and right.
Yeah.
All right, so we got the 2-dimensional figure contains angle C. So here's angle C. This is angle C right there. What kind of angle is angle C?
All right.
It's a right angle. Okay, so the answer is this one. Could you tell me an obtuse angle?
120.
Good. Excuse me. How about an acute angle? Do you see any acute angles?
60.
60. Very good. All right, so here's another chart for you to fill out. Just like we did in the previous problem here. Go ahead and tell me what you think. Give me your answers to this, please.
Okay. Okay, got it down.
Okay. What do you got for angle A?
Angle A, acute.
Okay, agreed. How about angle B
Obtuse.
and angle C?
Right.
Very good. All right. 3 for 3. All right, let's look at next one here. Do you have any new video games that you're playing?
No. Not right
No.
now.
Okay. Are you waiting on anything to come out, be released?
No.
All right. What about Taekwondo? That's what you're doing? Is that what it's called? I'm sorry if it's
I used to.
or jujitsu. You're doing jujitsu, right?
Yeah.
How's that? How's that?
Good.
All right. So the options here are, we'll just do it the same order each time. Acute, obtuse. I'm sorry, acute, right, and obtuse. What do you say? Is this acute, right, or obtuse, these angles in the octagon?
A obtuse.
Obtuse, yes. Very good. All right, so we're going to look at a square next. Is it acute, right, or obtuse?
Right.
You got it. Now we're going to look at what's called a rhombus. A rhombus, believe it or not, is like a square pushed over. So we've got acute, right, and obtuse.
A obtuse.
Anything else?
Acute.
Yes. It's a little bit odd to think that a polygon can have more than one type of angle, but it does. Okay, this is gonna be a little bit tougher for us to do. All right, Okay, so let's go through some more definitions. Unfortunately, we got to do a few more definitions. So this is a triangle. If all three sides are the same, so three sides same, it's called an equilateral triangle. So you want to know this word, equilateral.
Okay.
Have you heard that before?
Never.
Never. Do you see how it kind of has the word equal in it? EQIL.
Yeah.
That's how you remember it. You're like, okay, it's got an equal in it. All three sides are equal. It's equilateral. Let me know when you get that down, please.
Okay. Okay, I got it down.
Okay. The next type of triangle we're going to look at is called an isosceles triangle. An
Okay.
isosceles is when two sides are the same. That's called isosceles. It's a C. Isosceles.
Is it two E's?
Yeah, let me spell that better. ISOSCELES.
Oh, okay. Okay, got it down.
Okay, great. Now there's a couple of other types of isosceles that you might see. What angle measure is this right here?
90 degree.
90 degrees. So if the two sides are the same, this is also an isosceles. The isosceles is about having two sides being the same.
Okay.
Now the last one is called a scalene triangle. And this is when there's no sides same. And there's a lot of these that you can draw, but here's one of them. So this is called scalene. So you have to know all three of these words: equilateral, isosceles, and scalene.
Okay, got it down.
Okay. Let me look for some problems, otherwise I'll make a few up. Okay, here we go. All right, so let me snip this one in. And let me label the sides here. 8, 12, and 12. Is this equilateral, isosceles, or scalene?
Equilateral.
What does equilateral mean?
Three sides are the same.
Is this side the same as the other two?
No.
So it can't be equilateral.
Isosceles.
Isosceles. Yeah, the C is silent because there's two sides that are the same. You ready for another one?
Yeah.
Okay. You have those words down in your notes, is that correct?
Yeah.
Okay. 8, 9, and 16.
Okay. That is scalene.
Scalene. Scalene. scalene. Questions on that?
No.
Okay. All right, so here's another one for you to look at. It's got more information in it, but I just want you to look at these sides. Look at the three sides.
Okay. Equilateral.
Yes. Equilateral. Okay, very good. All right, so what do you notice about the angles in an equilateral triangle?
It is all the same.
Yes. So we can actually go back and modify our definition. It's not just that three sides are the same, three angles are the same.
Okay.
All right, let me know when you're ready for us to move on to another problem here.
Okay. Here we could go now.
All right, so again, just look at the sides. Just look at the three sides. Is this equilateral, isosceles, or scalene?
Isosceles.
It is isosceles. I agree. What do you notice about the two angles?
It is none. I mean, only two.
Two are the same. So not only in an isosceles are two sides the same, two angles are the same.
Okay.
All right. Now, a scalene triangle, we'll look at that now. I'm going to tell you this next one is scalene. This one is scalene. What do you notice about the side lengths? 6.1, 7.4, and 8.7.
None of the sides are equal, nor the numbers inside the
The
angles.
angles, yeah. So if we go back and modify our definition, no sides the same, no angles the same.
Okay.
Let me know when you get that down. We'll do a couple more problems before we close out.
Okay, got it.
Okay. So let's look at this triangle. Whoa, that didn't go in the right spot. So when you're looking at a triangle, you have to decide, are you looking at the sides or the angles? Like, are all the sides the same? All the angles the same? Two sides, two angles? What do you see here?
I see three angles.
Three sides, side, side, side.
Okay.
Are they the same?
Yeah.
So this is equilateral.
Okay.
Let's look at one more here. Look at the sides. Is this equilateral, isosceles, or scalene?
Equilateral.
So all three sides are the same. Do you know this third side?
No, it's isosceles.
It is isosceles, yes. Very good. All right, good job today, Michael. You did great. Very active in the lesson. I really appreciate it.